Safe drinking water is something we often take for granted. But behind every drop are treatment processes that safeguard your community's health. One of the most essential safeguards is your water treatment plant's disinfection process. Disinfection is a treatment process that kills or inactivates pathogens in your drinking water that can cause serious illness. In this video, we're going to explain the main kinds of disinfection used in municipal water treatment, their types, how they work, and what board member in small rural communities need to know about each one. First, it is important to know that water from lakes, rivers, streams, and wells can contain microorganisms such as bacteria, viruses, or parasites. Disinfection removes or inactivates these dangers before they reach someone's tap. Therefore, disinfection is one of the most significant public health achievements of the last century. In fact, before the introduction of the disinfection process for public water systems, it was very common for thousands of people in the United States to become ill or even die from waterborne illnesses. There are some important regulations for disinfection. For instance, for systems that use surface water sources, disinfection is a legal requirement. Although most groundwater systems are not required to use disinfection, unless their source water has been deemed to be under the influence of surface water, most municipal systems will still choose to disinfect to add an extra layer of safety, especially for systems with older or larger distribution systems. Chlorination is the most common method of water disinfection. The process of chlorination uses chlorine in different forms, such as gas, liquid in a bleach form known as sodium hypochlorite, or solid tablets or powders made from calcium hypochlorite to kill harmful microorganisms that may be in your source water. There are several advantages for the use of chlorine as a disinfectant. One of the most significant advantages of using chlorine in one of these forms is that it leaves a residual of the chlorine disinfectant in the water distribution system. This will help to keep your drinking water safe from the water treatment plant to the customer's tap. Due to safety concerns with handling chlorine gas, many small water systems will choose to use liquid chlorine or one of the various dry calcium hypochlorite products. Chlorine is affordable and effective, but it can react with organic matter in water to form disinfection byproducts, which are regulated by law. Chlorine can also cause taste and odor complaints if not used properly. We will explore both the pros and cons of gas chlorination. The pros of gas chlorination include: it is extremely effective against most pathogens, provides a residual of chlorine for your distribution system protection, and is relatively low cost. The potential cons of using chlorination include the potential for them to form disinfection byproducts. If not handled properly, chlorine gas can have serious safety concerns because it is extremely hazardous and it may not be ideal for small systems. We will now look at another potential disinfection process known as chloramination. Chloramination uses a combination of chlorine and ammonia to produce chloramines. Chloramines are less effective disinfectants but persist longer in the distribution system, aiding in maintaining a weaker but long-lasting residual in extended distribution networks. Chloramines also produce fewer regulated disinfection byproducts, and used correctly may help systems have fewer taste and odor issues. However, this method requires careful chemical control, regular testing, and monitoring for a condition known as nitrification, which is a process where bacteria feed on ammonia and decrease water quality. Now let's look at the pros and cons of using chloramination. The pros of chloramination include that it creates a long-lasting residual with fewer disinfection byproducts and could reduce taste and odor issues. The cons are that it is a weaker form of disinfection, there is a risk of nitrification, and it does require close monitoring of ammonia levels. Next, we will look at a potential disinfection process known as ultraviolet disinfection. Ultraviolet, or UV disinfection, uses light to scramble the DNA of microorganisms, making them unable to reproduce. It's very effective against bacteria, viruses, and even parasites like Cryptosporidium, and it doesn't add chemicals to the water. However, UV offers no residual protection. Once the drinking water leaves the treatment plant, it is vulnerable to contaminants that could enter the distribution system from leaks and main breaks. Therefore, UV is often combined with a small amount of chlorine to ensure the drinking water remains protected throughout the distribution system. UV systems also need regular lamp replacements and cleaning to function properly. Now, we shall look at the pros and cons of using ultraviolet disinfection. The pros of using it include that ultraviolet disinfection uses no chemicals that may cause taste or odor issues. It is effective against a wide range of pathogens, and it is fast and reliable. The cons include that the use of ultraviolet disinfection does not create a residual in the distribution system, is really only effective for low turbidity water, it requires a considerable amount of power to operate, and requires a significant amount of maintenance to ensure that it continues to work properly. There are federal regulations that could affect which type of disinfection process you choose. So let's look at a few of them. Federal regulations require most systems to maintain a detectable disinfectant residual in their distribution systems while meeting any limits set for disinfectant byproducts. Whether you use chlorine, chloramine, or UV, you must comply with EPA standards and keep detailed records of disinfectant residual levels. If your system doesn't maintain a residual or exceeds disinfection byproducts limits, that could be a violation. You'll need to take corrective action and may have to notify your customers. Finding the right process for your system isn't always straightforward, and there's no single solution that fits everyone. The most suitable disinfection method for your community depends on your source water quality, your system's size and layout, your operator capacity, the cost of the process, and finding funding for it, the needs of your system and customer, and your best disinfection option to maintain regulatory compliance. Most small rural systems use chlorination because it's simple and effective. But alternatives like chloramine or UV may be worth considering in certain situations. Your role as a board member is to support informed decisions that keep your system safe, sustainable, and in compliance with regulations. Your position as a board member requires you to be a strong advocate for safe drinking water, as well as helping to create a strong community. It is not an easy task, but there are people and organizations like the Rural Community Assistance Partnership that can assist finding the right disinfection method, and can also support you with making your water system stronger and more resilient. For more information on how RCAP can assist your utility, and to access additional resources, please visit our website at rcap.org.